In today's lesson, I'm going to walk you through a step-by-step guide of how to turn full balanced equations into ionic equations. This is something that comes up in GCSE chemistry all of the time, and for the most part, students tend to find it quite difficult. So I hope today's step-by-step guide will be helpful. In today's video, I am going to teach you how to write ionic equations that it's just one of the necessary skills you need to know for GCSE chemistry, as well as grade 9, grade 10 chemistry if you're in the US. Usually when you're given full equation, a question I'm often asked by my students is, how do I turn that into an ionic equation? So I'm going to outline some very simple rules to follow so that you get these questions correct every single time. And then I will attempt a couple of these examples, and then the remainder I would like you to do, and then you can check your answers using the mark scheme I've attached below. So let's take a look at the rule first of all. Number one, you are only allowed to split species. Species, by the way, is like the term we use in science for anything. So a molecule, an atom, an ion, whatever it is, right? So that's the term I'm going to use going forward. So the species could be like, you can see sodium carbonate there, zinc chloride, potassium nitrate, just anything you see in the equation, basically. So you are only allowed to split species with an AQ state symbol. AQ, by the way, means aqueous. It means dissolved in water, or in other words, a solution. Number two, anything with a solid, liquid, or gas state symbol you leave alone. Okay, you don't do anything to it. Now, I'm just writing these rules in normal, everyday speak, everyday language for your understanding. So nothing complicated here. So to summarize, you can only split things that have an AQ state symbol. If it has a solid, liquid, or gas state symbol, you leave it alone. Right, so let's put that into action with some of the examples. So I think we'll try number one. And I'll write this one down the bottom. So we have Na2CO3 AQ plus hydrochloric acid, 2HCl AQ goes to sodium chloride, 2NaCl AQ plus water liquid plus CO2 gas. Right, so let's put this rule into play. So what things have an AQ state symbol? So this one does, that one does, that one does, water doesn't, and carbon dioxide doesn't. So I'm going to split the things which have an AQ state symbol. So sodium, the charge in sodium is 1 plus. How do I know that? Because it's in group 1 and there's 2 of them, so it'll be 2Na, so 2Na plus because there's a 2 next to it. And then the charge on the carbonate ion is CO3 2 minus. Okay, so carbonate, nitrate, phosphate, hydroxide, those are known as compound ions, and for those you just need to know the charges, right? I've covered this in another video. The link is below in the description. Right, plus 2 lots of HCl, so 2 lots of hydrochloric acid molecules, so there'll be 2 H pluses and there's 2 Cl minuses. Why have I put a 2 before it? Well, there's a 2 there, so there's 2 lots of it. Then on the right hand side we have 2 Na plus and 2 Cl minus. And then the water, I'm just going to write that literally the same as it was before because I'm not allowed to split it because there's a liquid state symbol. And the same for the carbon dioxide, that's a gas. Right, So to create the ionic equation, the next thing you need to do is cancel out things that are common to the left and right of the equation. In other words, that are exactly the same, right? So we take a look at the left hand. See if I use a different color to show this. So the left hand side, we can see we have 2 sodiums there, which I can cancel with the 2 sodiums there. The left hand side also has 2 chlorides, which I can cancel with the 2 chlorides on the right hand side. And then if you look at what's left, I've got water on the right hand side, a carbon dioxide on the right hand side. There isn't a water or carbon dioxide on the left hand side, so they stay as they are. And then I've got 2 H plus, and there's no H plus on the right hand side. And I've got a carbonate there, CO3 2 minus, and there isn't a carbonate on the right hand side. So again, I'm not allowed to cancel it. I leave it as it is. So my final answer, if I just write it here, final will be CO3 2, typo there, so CO3 2 minus plus 2H plus goes to H2O liquid plus CO2 gas. That is the final ionic equation. Okay, right, I will do one more, and then the other two you can try yourself by, as I said, checking your answers in the mark scheme below. And don't cheat. This is for your own benefit. So let's try number 3. Okay, so we're going to split this into the ions. So again, only split AQ species. Anything else, you leave it exactly as it was before. So chloride is in group 7, so has a -1 charge. So there's 2 of them, so it's 2 Cl minus. And then, which means for this to balance, that must be copper 2 plus. The zinc, exactly the same as before. Zinc chloride is aqueous, so I can split that. So chlorides is 2 chlorides, both have a 1 minus charge. How do I know that? It's because, as I said, it's in group 7, so it's a -1 charge, which means the charge on zinc will be a 2 plus. And then we have copper is a solid, and that stays exactly the same. So if I look on the left hand side and the right hand side, if I just cancel it out in green, the only thing that is common to the left hand side and the right hand side is the chlorides. So that and that. I'm not allowed to cancel the copper because that's copper 2 plus. That's not the same as copper. They must be identical to cancel out left and right, okay? So I'll leave that alone. And the same goes for the zinc. So that's Zn2 plus and that's Zn. So they're not identical. So thus I'm not allowed to cancel out. So then my final answer for this one is going to be, okay, so that leaves you with question 2 and question 4 to complete yourself. So have a go at those now. If you're wondering how to write state symbols, so for example, how did I know potassium sulfide is aqueous and iron sulfide is solid and so on, then I have produced a video on how to write state symbols. The link is in the description below. So check that out, because lots of questions have equations which don't have the state symbols, which means you may struggle to write the ionic equation if you don't know what the state symbols are. And if that is the case, you will have to put the state symbols in yourself so that you can at least work out what the ionic equation is going to be. So go and check that video out as well. If you have any questions, please comment down below. If you've enjoyed today's video, like and subscribe, and please check out all of my other videos on GCSE chemistry, physics, some maths in there as well. And I will see you in the next one.